I'm going to have a point right here, and I'm going to call it x1, y1. That's the coordinate of that point right there. That could be any point. I haven't specified x1 or y1. I'm going to specify a second point, x2, y2. I want to know what the exact distance is between those 2 points. This is how we're going to do that. I want to know this distance right here. First, I'm going to construct a right triangle. Oh, thank you. What's the x-coordinate at that bottom right? What's the x-coordinate right there? Yeah. x2. Because it has the same x-coordinate of this point, right? Can someone tell me what the y-coordinate is right here? y1. Very good, yeah. Can someone tell me, this is a little trickier, can someone tell me the length of this side right here in terms of the coordinates? It's a horizontal line. How long is that side? What? x2 minus x1. Because how far over is it to the right? No, don't look at the. It's x2 over to the right. How far is it over to the right here? x1. If I have a number line, and I'm at B here, and I'm at A right here, what's the distance between the two? B minus A. If I'm at 6 and 4, what's the distance between the two? 6 minus 4. It's 2, right? So if I'm between B and A, how far apart are they? B minus. So if I'm at x2 and x1, what's the distance between the two? Exactly. Now what about the y-coordinates? How high is this? Someone else. How high is that triangle? Yeah. y2 minus y1. There's a theorem that many of you have heard of and many of you have used. It begins with a P. What kind of triangle does it apply to? Pythagorean theorem. Given a right triangle A, B, and C, a squared plus equals. So we want to know what this distance is. We don't know what that distance is. But we know some side lengths, right? What's the base here? Minus, or plus, sorry. Plus what? What's the height? y1 what? Equals what? D squared. So if we want to isolate D, if we want to get D all alone, it's squared right now, what do we do to both sides? If you want to get rid of a square, what do you do? Square root. We now know that the distance is equal to the square root of x2 minus x1 squared plus 2 minus y1 squared. What does that mean in concrete terms? Let's say I gave you 2 points. 2, 3, and -2. How about this? -1, 5. If I wanted you to find the distance between the two, does it matter which one you label x1, y1, and which one you label x2, y2? No. As long as it's x's and y, exactly. So let's say x1 and y1, and call this one. So we subtract the x values. -1 minus what? 2, and we square it, and then we add 5 minus, and then that's going to be -3 squared plus 2 squared, which is equal to 9 plus 14, so that's equal to the distance squared.
9 plus 14.
Plus 4, sorry.
Oh,
plus 4. So what's D equal?
13.
The square root of 13. You have to square root it because it's D squared. Right. What does this allow you to do? What does this formula allow you to do? Yeah. Yeah, any 2 points. It allows you to find the distance between any 2 points. Exactly. Okay, so now let's go on to that homework question. And x equals? I gotta change colors again. X equals 5, and y equals 2x minus 4. Where's that going to cross the x-axis? At 2. Thank you. Where does it cross the x-axis? That's when y is 0. So when you make 0 equals 2x minus 4, what does x equal? 2. So it's a slope of 2x, so it goes like this, right? Correct? So this equation, so you have this right here. So it's asking you, are these triangles congruent? Well, we have a lot of horizontal lines, which is kind of helpful. So what does that tell us? This side is, well, how about this? A, B, C, D. AB is congruent to?
DC.
CD, but it's the same. It's fine. And you know that DA is congruent to?
CD.
And you know that this is congruent to itself?
Yep.
So are the two triangles congruent?
Yes, sir.
By what?
By side, side, side.
Yes. By side, side, side. Exactly. Right. This one's pretty nice because you have horizontal lines. Is it really easy to find the length of horizontal lines?
Yes.
Yes. What happens if we tilt these triangles? Does it become trickier? Yeah, it does. For example, let's say I gave you a triangle that looks like this. Let's say this one was 2, 2. This one was 0, 7. And this was 4, 6, 7, 9. Don't need to do either. I'm just asking you for what are the lengths of the three sides. Go. Find the lengths of the three sides for me. A to B, A to B. Raise your hand. Someone, A to B. Missy. Who agrees with the square root of 29? Who agrees with the square root of 29 for A to B? Let's do A to B then. Okay, so you have the 2 points, 0, 7, and you have the other point is 2, 2. So you have 2 minus 0 squared plus 2 minus 7 squared. What's that equal?
Can we go slower?
Sure, absolutely. A to B. So we have x1 is there. Where's x2? y1 is there. Where's y2?
2.
What's 2 minus 0? That's x1 minus x2.
Doesn't that only work for...
Nope, it works. Oh,
You told us
yes.
didn't know if they're right triangles.
This is not necessarily a right triangle, but this is a right triangle. Ah. This is a right triangle. This triangle that I drew is not necessarily a right triangle. That's correct. So you use, what's this distance from here to here? What's that distance? 2, which is 5. We can say negative 5 because we're squaring it. And what's this distance right here? What's that distance? 2. What's 2 squared plus 5 squared? 2 squared plus 5 squared? 29. That's the distance squared. So what is the distance? The square root of 29. So that's this one right there. If we want to do the next one, let's do B to C. If we want to do B to C, B to C, what right triangle are we talking about? It goes up and over, right? There's the right triangle. How far up do we go? How far up? 9 minus 7, which is 2. How far over do we go? 7, 0, which is? What's 9 minus? Oh, 2 squared is? Plus? So it's the square root of? 53. Correct.
Question.
Yes.
Can you just know that it's 9 because, like, would it be 9 because could you take the square root of 4 first and the square root of 49?
Absolutely not.
Okay, that's what I thought.
1 squared plus 2 squared does not equal 3 squared. Always remember that. Always, always, always remember that.
Yep.
Never, ever, ever do it separately.
Wait, so how come those ones are all inside of the squared thing, but on AB you didn't do that?
I did, because this was d squared. Sorry.
Oh, okay.
This was d squared right here.
Yeah.
You got that?
So your final answer can look, it just has a square. All right.
That's correct. D. Sorry, the pen just stopped working. Squared. Okay? We could draw it as 6, 8. This is 10. I'm sorry. 6, 8. This is really hard. 10. Are these similar? 6 is to 3 as 8 is to 4 as 10 is to 5. These triangles are similar. What's the scale factor if you went from this triangle to this triangle? What's the scale factor? 2 times, yes. What's the scale factor? There's a little dot here. Times 2. What's the scale factor if you went the other direction? What? Yeah, times 1/2. Absolutely. The scale factor depends on which one's starting and which one you're ending up with. Does that make sense? So essentially, can you resize the shape to be exactly the same as the one you're targeting? If so, then the shapes are similar. They're similar. Are congruent shapes similar?
Yeah.
Sure. What's the scale factor? 1. So all congruent shapes are similar. Are all similar shapes congruent? No, they're absolutely not. Absolutely not.